Welcome back. Right now we want to calculate the reaction or best response functions for our two basketball players, Curry and Durand. They have identical preferences, so I'm just going to focus on Curry. What we do for Curry, we do for Durand. The only difference is that they have different budget sets. That is, Curry has 50% more money to spend than Durand. They can talk about that at contract renegotiations. Anyway, we've got Curry's utility function is the log of s minus 6, which is the total number of seats, plus the log of xc minus 3, where xc is other stuff. Remember, x, other stuff, he consumes privately, and seats, he consumes jointly. So we have this public good or this positive externality. We have what we sometimes call not well-defined property rights. Okay, well, we know that the marginal rate of substitution is equal to the ratio of the marginal utilities. The marginal utility of x for Curry is 1 divided by xc minus 3. And the marginal rate of the marginal utility of seats is equal to 1 over s minus 6. So the marginal rate of substitution is the ratio of these two, which equals 1 over xc minus 3 divided by 1 over s minus 6, which equals s minus 6 over xc minus 3. So that's the marginal rate of substitution of x for s for Curry. Okay, and if I just change the x subscript to d for Durand, we'll get the same thing. Now, for tangency, we know if the indifference curve is tangent to the opportunity set, we know that the MRS must equal the price of other stuff divided by the price of seats, which equals 1, or s minus 6 equals xc minus 3 equals 1. This is tangency. Okay, or that's telling us that s minus 6 equals xc minus 3, or xc equals s minus 3. That's our tangency condition. Okay, now for utility maximization, not only do we have to have the MRS equal to the relative price ratio, but we also have to be on the consumption opportunity set. So we're going to substitute this into our budget constraint. All right, let me erase and come here. We have 36 equals the seats bought by Curry plus other stuff bought by Curry. And we have xc was equal to s minus 3 and s is equal to the seats bought by Curry plus the seats bought by Durand. So we have 36 equals SC plus SC plus SD. Or I forgot the minus 3 there. Or 39 minus SD equals 2SC, or SC equals 39 over 2 minus 1/2 SD. That is Curry's reaction function. Okay, so if I come here, I'll show you the calculations. And I do the exact same thing for Durand, and I see that his reaction or best response function is 27 over 2 minus 1/2 SC. Okay, so these are our two reaction functions, and we're going to see where each would want to be. Okay, and this is going to give us our Nash equilibrium. What we have here is what's called a duopsony. Usually we think of two producers. Well, here we have two consumers. With two producers, we would have a duopoly, which is like a two-firm form of oligopoly. Well, here this is duopsony, where we have two buyers, which is a two-person form of oligopsony. Oli meaning some, but not a lot. All right, so let me just come back here. We'll take a look at this. All right, we've come through here. Those are
artistes. Here you go.
All right. So we see that the margin rate of substitutions, we got our best response functions, and now we will come back and solve for the optimal amount of seats purchased and other stuff purchased in our next session. I hope to see you then. Thanks a lot.